Everyone, welcome to another AP Environmental Science lecture. We're going to wrap up the chapter on Earth systems, looking more into detail with mining. So we've gone over the plate tectonic cycle, the rock cycle, how soil forms, and everything that kind of influences the distribution of rocks and minerals on Earth. So the reason why we're finishing on mining here is that these resources, along with those fossil fuels, they exist, but we have quantities that are going to run out. So it's important in environmental science to not only find these resources, extract them sustainably for human life, but we're also going to look at some of the important non-fuel mineral resources and how we obtain them. But we're also going to look at the where they're abundant and where they're rare and what makes them extremely valuable. So before we get moving, we saw that at the beginning of this chapter that, we had the early Earth cooled and differentiated into these distinct zones. You had the inner core, the outer core, and so on. And what happened is a lot of the heavier elements like gold, copper, those sank towards the core, whereas the lighter elements like oxygen, silicon, what you can see in this pie chart, those are more abundant in the crust. So the chemical composition of the crust, which you see here, this is pretty much 88% of what's going on, but it is going to change depending on where you're at. So looking at mineral resources, so we know they're naturally occurring. We're going to see how they're made within the earth in a bit here. We know that these must be extracted and processed. You'll see that in labs through this chapter, and some examples like how you get to school or how you use energy to heat your home. We need these resources for energy. We need the metallic minerals like aluminum, iron, copper, gold, aluminum in airplanes. A lot of the metallic minerals are especially helpful when using electric current, so electricity. And then our non-metallic minerals, these are a lot of our building supplies, so like aggregates, even fertilizers, and then even evaporites like gypsum that we find in your drywall. And I'm sure at home you may have marble, limestone, or even granite as countertops. One thing that is extremely important to note is that these are non-renewable. So, looking at this table, how many reserves are remaining, and then where in the U.S., and then it's also important to note how many years we have left. So again, these are finite, these are going to run out. So it's important that we know the locations of where these minerals are and how to extract them sustainably, but also how to keep their supplies going into the future. So what is an ore? An ore, what we're looking at is just this rock that contains a mineral. And again, we cannot go and just pluck the gold out of the rock. There's a whole process of refining and things of that nature. So an ore also has a profitable amount. It's worth some money. And you can have those high grade like lithium or platinum, and even low grade. Sometimes when they're mining for silver, there's some gold offshoot as a result. So you can have your high grade and low grade ores. So looking at how these are created, these ores are formed by different geologic processes. So some ores form when magma comes into contact with water. This will heat the water, create this solution where the metal will precipitate out of, and you see that in the picture here. There's a vein of gold. That's usually a hydrothermal process involving that hot water. Or you can have these manganese nodules, which are quite interesting. You have this on the sea floor, obviously you have water movement, so you have weathering going on, but these nodules will they react with compounds in the seawater, and they deposit as these kind of little round, again, like we call them nodules. So we see them here, and that's a great example of manganese. And this is where a lot of our steel comes from. So even the sea floor, we're mining and refining minerals. Other ways through the sedimentary process, you have this person here, a placer deposit. Is just, remember, water will carry certain sediments, and gold is one of them. Gold would fall out in bends in a river. That's where you have this person panning for gold. And then also with the water process, you have evaporites. So you have water, there's a solution of minerals in it. The mineral or the water evaporates, and what's left behind are the minerals like halite. That's just salt, gypsum, which you find in your drywall, and even some of the things you use in your soap. So we have a picture here of a placer deposit. Back in the day on the top right, you had your gold miner panning for gold. Still kind of do it the same way today, just involves a lot more heavy machinery and go through a lot more sediment much quicker. And finally, another way we get mineral resources is through weathering. So you can see all those little circles, that's bauxite. And through the process of weathering, that aluminum was formed, and another way to get the resource. So where are we in regards to our resources on Earth? So we know there's quite a bit of identified. We know the location. We know how much is there. But it is important to note that that the global supply is sometimes difficult to quantify. And the reason why is because private companies own land. And if you're a private company and you're mining on a certain area of land, you hold the rights. Therefore, information about the exact quantities isn't always available to the public. The company knows, and they might let some details out, but we don't know the whole story. So that's one example. So we know where our reserves are. That's where we've identified resources, where we can extract. Will we make a profit, once we start digging up and extracting? And then finally, there is a little bit of undiscovered. There are some potential supplies that are assumed to exist in these places. Some are, for example, underneath the ice sheet in the Arctic circles. So we know they're there, just very difficult to get. But again, for most part, we know where most of the mineral resources are on Earth, and we've kind of utilized their existence. So just looking at this map here, again, there's really not anywhere in the world you can't go where you find some sort of mining operation taking place. So looking a little bit closer, so take it into your lifetime. So 3.7 million pounds of minerals, metals, fuels in your lifetime. All these things have to be extracted from the earth, have to be refined, have to be sent to you, and giving us our standard of living, you could say. So, how do we get these minerals? Things like gold. Or I shouldn't have said how do we use? So gold is found obviously jewelry, but our electronics, aluminum, a very light metal, so packaging, cars, airplanes. Steel is in almost all of our buildings and vehicles. Well, then we can even get to the sand. It's found in every glass window you see, bricks and concrete, and then even limestone is in our building materials of roads and concrete as well. So what we're going to look at here is how the life cycle of a metal resource. So again, I keep saying, these things just they go pick them off like you'd pick fruit off a tree. There's a lot of, a huge process going on just to get the products that are found, in this case, your car, your iPad, your computer, even in your home. So we'll look at some things, terms that when we are mining for resources that we're going to be left with. The first thing is an overburden. So think about it. You want this coal, you want this gold, whatever it is you want to extract. Think when something's a burden, it's kind of hinders, gets in the way. So overburden is just this soil or rock that usually lies above the material. We got to dig through it. We got to take it away before we can get the resource. Funky way of spelling it, but this is just pronounced gang. So it's the worthless minerals or material that surround the ore. So you can see the picture on the left. You see the gold veins in that rock. The gold is what we want, but unfortunately it's surrounded by a lot of gang. So in the picture on the right, there's just the pile of that gang. We got the gold out. Now we have these worthless materials left over. Smelting, you can see here, sometimes we have to, and this goes a lot, especially in mining metals like silver, gold, platinum. You have to smelt them, and you've seen those bricks of gold. That's the result of smelting. They have to melt it down, and then it'll reform and just to the purest form into the use when it's more usable. Tailings, these are pretty wild. Again, you have a mining company, they'll get the resource they want, and as a result, you get some tailings they in the picture on the left, they just leave in a big pile, or they kind of they manipulate streams and waterways where they'll try to hold it in a certain water as it slowly cleans. And this is kind of sketchy just because a few years ago, you can see that picture on the right, all the tailings in that river, the tailings leaked out, and horrible way to get out of water. So a large and a pollutant, especially for our water, even in our groundwater. So here's just an example of showing you what they try to do. They try to put them in these aquatic little holding areas. The the water, the goal is the water evaporates out and the tailings are left behind. But again, kind of a risky thing to do. And here again, here's some tailing waterways being polluted. Nasty stuff. So there are obviously good things for mining. It's not a bad thing. Without it, we wouldn't be here. I wouldn't be talking to you through this device. You wouldn't be in your room right now enjoying this amazing lecture. So we do have advantages. There is an income. It does bring us money. Cities, states, I mean, especially Nevada, it's a huge mining state. So it's bringing in income, giving jobs to people, and then even progress. Again, Tesla, the reason Elon Musk built his headquarters in outside Reno, Nevada, because there is a huge amount of lithium in northern Nevada. So, if what you're mining and what you need for your product is lithium, why not build your headquarters near the resource you're using? Disadvantages, though, mining uses a ton of energy. We're going to see how it disturbs the land. Soil gets eroded away. You have all this waste you're left over with. Air, water, soil gets polluted. Not a good thing. So we're going to look at, there's two ways. You can mine from the surface and you can mine below the surface. So with surface mining, our examples are on the right. You're going to have to know each one. But what we're doing is they're close to the surface so we can remove these shallow deposits. That overburden, which we mentioned earlier, is removed. And then the mineral is extracted. But again, unfortunately, that overburden is just discarded as these spoils. And they'll fill in valleys or they'll fill in waterways, and not a good thing. So most of our non-fuel mineral rock resources, so like sand, gravel, things we use for cement, but also coal. Coal's pretty close to the surface, and 60% of the coal mine in the U.S. is from surface mining. So here's some examples, especially on the foreground on the left-hand side of this picture, some ways of surface removal of these resources. And we'll go over some of them right now. So open pit mining, exactly what it sounds like. So you have this big hole in the ground. So you just constantly dig this pit. You can see they're kind of circular. They work from the outside, work their way in, and just constantly bringing material out, sorting through that material. And again, they get the gold, silver, whatever they need, but imagine all that material that they dug up has to go somewhere. So that gang, that tailings, that's where they build up. Strip mining, what's happening here is you're just taking a big strip of land. It's found, you'll see horizontal beds. So you can see here, there's probably coal, alternating layers of sediment, coal, sediment, coal, sediment, coal. So they have to take the land away in strips. Here's an even better example of what I was just talking about. So you have usually in a hilly environment or topography. And what they'll do is they'll just remove the little strips that they need. Mountaintop removal, another example. It sounds exactly what it is. They just literally take the top of the mountain, remove it, take those resources out. Again, this is happening a lot in Appalachia, coal, and they'll try their best to put the land back where they got it. Gold mining, so these metals are usually with placer deposits. So when you have gravity separating, gold is pretty light compared to a lot of the other minerals or metals that are going through in this case, the water. So started out with panning, but now dredging is kind of like the panning on steroids. Or even just hard rock deposits. You go right through, you drill into the mountain. Hydraulic, we're using water with mercury just to blow out that rock and get those minerals and those ores. And even cyanide, especially with gold, they use cyanide. The gold will separate from the rock when they soak it in cyanide, which is obviously a harmful pollutant, but they are able to extract that gold and they're left with that gangue. So now we're going to go subsurface. So again, subsurface, now we're removing deposits that are found deep inside the earth. And again, metal ores, remember when the earth was forming, the heavier metals sank towards the center, lighter metals lighter to the top. So our heavy metals we have to go deep into the mine. So just as you'd imagine, they dig this deep vertical shaft into the earth. you're blasting tunnels, and you're using these machineries to reach those deposits. And you have many different types of subsurface mining. This just gives you an idea. So, you have to go deep into the earth, and what they'll do is they'll just, again, they're extracting, they're putting up pillars so the surface, so the top of the mine doesn't collapse in on itself. This is a little more dangerous than obviously working at the surface. Fracking is a big thing now, just because one reason is we're running out of easily available resources. So with fracking, we're going deep into the earth just to get natural gas out of these shale layers where it's trapped. It's using water. It's the combination of pumping water into these cracks in the earth, and as a result, these cracks will increase. And once they remove the water from the well, the cracks that the water created, gas will seep in, and then all of a sudden they just take the gas out. So still quite a bit of issues with fracking. Earthquakes happening, groundwater supplies being polluted. So a lot of questions to answer in regards to fracking, but to determine if it's really safe. This map just shows you an idea of where it's all happening. So you can see there's a lot of natural gas. And again, natural gas is a clean fuel. It's much better than coal and oil in this case. But again, it's the cost benefit. Is the negative things happening to the environment, to water supplies, worth extracting it from these places? So what does happen? We've kind of hinted at that, there are some negative effects to mining, and we're going to go over some of the main ones right now. Disrupting the land is a huge one. These things are buried deep inside the earth. You have to bulldoze, you have to dig them up. And then again, all that overburden, all those tailings, all those spoils are left behind. And even how we mentioned cyanide, sulfuric acid, all these things that have to be done to get that ore, but a lot of it is left behind. Loss of topsoil. We talked about topsoil, how essential it is, not only for the earth, but for human species and growing crops and things of that nature. A lot is lost. And subsidence, what happens, just imagine if you're digging deep inside the earth, a certain material, whatever's supporting the top of the crust is going to fall out. So we see subsidence as well, sinkholes, things of that nature. Again, we already mentioned kind of gold, processing gold. You need heavy metals like cyanide, mercury, things that are quite toxic that could end up in water. Tailings, there's a crazy story in, I believe it was Oklahoma, that these tailing piles were just left after they were mined, and kids would go and play in these tailings, and all they were playing in was like lead and mercury and kind of scary stuff. And through wind and through water, they'll end up in the ecosystem. And then even processing. So we have to, burn fossil fuels to get these, and air pollution will result as well. So it's quite hard to believe that a majority of the industrial pollution is coming from the extraction of mining. And this is a great table. I would maybe screenshot this because you're going to need to know the effects. We have our two types of mining. We have our effects on all the resources, the air, the water, the soil, life, and then even humans. So give it a quick screenshot. Make sure you refer back to it for understanding. We know we have to remove forests. So there we have our loss of biodiversity. Removing forests increases that erosion. You don't have the trees there to hold the soil in place. We can have diseases underground. You've heard of coal miners spending their whole day inside of a coal mine. So bronchitis, emphysema, I'm sure you've heard of black lung disease. And then moving forward, how do we fix this? We can see the mining before. We do our best to reclaim the land on the right. So right nowadays in the United States, that mining companies need to clean up and restore the damage they cause. So currently there's about 500,000 sites in the U.S. It costs $70 billion to clean up. Subsurface mines don't disturb as much, but again, and they also produce less waste, but it all again depends on where the minerals are. If it's near the surface, you're going to have to do that surface mining, which results in much more cleanup and much more restoration. There have been some attempts. The 1872, though, general mining law, this wasn't more for the environment. This was more to encourage people to come out west. You could come out west, and under this law, you could claim land. And claim was not expensive, $6 to $12 to buy the land, $500 to improve it. When it's all said and done, the people would do the land, $500 was not going to fix what they did. Stopped it in 95. But again, still, some people were still buying land for about $12 during this time. And it's crazy. Over 100 years passed, and finally they said, we have to clean up the mess that you make if you do choose to mine that land. And of course, these mining companies are trying to weaken because, it hurts their top margin. They lose money having to restore the land. So what we have now is, in 1977, we have the Surface Mining Control and Reclamation Act. So here we're now starting to take care of the environment. We're holding mining companies responsible, making them, you came in, you took a resource from the land, you made money from it, but you need to reclaim the land. So to make up for those impacts it had on the fish, the wildlife, and any other things that happened in the environment. So that's where we will end the chapter. Make sure you know about this act. Make sure you know about the 1872 as more to get people out there mining rather than for the environment. And there's still a ton of legislation that goes on even now. Closer to home, they're removing federally protected land. So you can go out like places like the Grand Canyon and mine and things in that nature. So it's very important. It's a very pressing issue. It's we like to keep our way of life, but there's a way to do it to live sustainably and protect the earth. So keep those things in mind. See ya.